Today we're having a prescribed fire webinar about prescribed burns and kind of walks us through the lessons of did you meet your goals and objectives of your burn plan that you set out to do. Well, we have Gabe DeJong, Virginia McDaniels, Beth Buchanan, just incredible people that have done this for a long time. So with that, I want everybody to realize this is pre-recorded. So they went out in the field and did some recordings on this, which I thought was super cool. So the volume might be a little low, so please turn up your volume. Please turn off your cameras during the video if you have lagging. Also, please put your name and whatever you want to share with people in the chat. That way people can see who's from where and what your interests are. And then also questions in the chat as well, or comments. We have Liz Rank from the Fire Learning Network National and Emily Holman, also the lead of that group. Both of them have been chaperoning this on this process. We're all used to somewhat Zoom, but not used to the logistics and pre-planning of it. So thanks to them that hopefully we'll be able to share with you what we put together. So with that, I think that's it in the intros. If I missed anything, Liz or Emily, please put it in the chat. I'm going to let Gabe Dijon share his screen and we will start the process. So thank you everybody for coming to see the show today. Welcome. Thanks for joining us. Does your prescribed burn meet your goals and objectives outlined in the burn plan? Today we're going to hear from some incredible fire ecologists and dear friends who think about this daily. I heard a saying somewhere recently that said that fire is a biophysical process, but fire management is a social one. And we're going to touch on that more thoroughly today. Today we have Virginia, Gabe, and Beth sharing with us their deep knowledge and understanding of how a simple and quick monitoring assessment can help you determine if you did what you set out to do in your burn plan. Hitting on that social parameter, we have been blessed to be a part of the North American fire networks on our journey and meet so many incredible people from all across the U.S. and the world. It's been amazing. We've learned so much from all the different perspectives and have incorporated many of those lessons learned into our kind of daily, monthly, and annual work streams to build a better fire management program here in Arkansas. And so this webinar is our way to share some of the nuts and bolts and get in the weeds a little bit in how our prescribed burns can be traced directly to the social and ecological outcomes we want to achieve. So, what differentiates planning for a prescribed fire from a wildfire? Well, two things really. You have time and accurate information on your side. These two items allow us to develop a solid burn plan to accomplish our broad goals and specific burn objectives. The question is how do we gather that information? And you'll learn more about that later. First up is, why do we burn? Really? I mean, because it's fun? Well, I would say we burn to achieve broad land management goals as well as specific objectives under the umbrella of some significant legal, safety, and health challenges across a broad spectrum of societies. But we get to determine the burn units, the burn timing, seasonality, frequency, and if we're doing our homework correctly, potentially to impact some severity. So why do we burn? Well, we burn for many, many, many reasons, and I'm going to go through a litany here real quick. But one is for specific forest management goals. This overstock stand, for example, might need to be thinned. Hadn't had fire in it a long time. Thin it out, reduce some of the overstory and mid-story for that matter. Well, for native plant and prairie restoration in the grasslands, or cattle and buffalo forage requirements. You know, a lot of landowners burn for grass forage and regeneration, or in this grassland to reduce invasive species or unwanted plants. So many reasons just in grasslands alone. There's lots of ecologists out there and botanists who burn for the incredible floral diversity out there, such as these flowering plants here found in Arkansas. Um, and in this picture, more of that floristic diversity. You know, that's rough coneflower back in there. But finally, you know, we conduct prescribed burns for wildlife habitat, ticks and poison ivy reduction, endangered species restoration such as red-cockaded woodpecker or the American burying beetle, or like some of our partners who manage drinking water supplies, water quality and nutrient reductions are a key burn goal and objective. Needless to say, there are many different goals and objectives I've identified in the burn plans over the years, but the question is how do we track it simplistically and effectively? We know restoration in many different ecosystems can and in fact is working. And it takes decades and many burns to begin to see really powerful on the ground results that you can walk through and appreciate. Just like Theo Witzel here from Arkansas Natural Heritage, chief ecologist. But getting there, man, it can be a challenge, which is why developing a simple first order fire effects monitoring tool for your program can really help guide you on the path of restoration, because that's what we did and that's what we are doing, and we hope to share that with you throughout this webinar. As I said earlier, you know, fire management is a social endeavor, and we cannot work in fire without partnering and quote, quote, learning by doing with people in our landscapes. It is so fun to be out burning with people and sharing the outdoors with people doing something you love. You know, here in Arkansas, like in many states, the Prescribed Fire Council is a powerful collective where we teach, practice, learn, and share local knowledge and the best available science on fire management. The Burn School, quote, quote, what we call it, hosts about 50 students a year from all across Arkansas. Over the years, they've trained over 600 people from almost every agency and nonprofit in the state that has connections to land and conservation. It is here where burn planning and monitoring is integrated, learning first order fire effects tools and techniques, and then integrated into the next generation of fire practitioners. Yeah, burn crew, man, it's awesome and it's incredible responsibility. But how we do it and measure success annually? You know, how do we measure success annually? Most of us measure this by the number of burns accomplished, the total number of acres treated annually, and that is great. Those metrics help quantify the operational side of fire. But what are we missing in that? What else do we need to be looking at? What else can we see? What else can we monitor? What else do we need to document and report for future burn bosses and ecologists? We're not all ecologists and only know a few trees and plants by name, and that's okay. But if we do not do something simplistic monitoring and documentation, we're missing the key. How our fire is shaping the landscape over time, and what can we learn by training our eyes to see the things we do not know what is there. So with that, let's see what Gabe and our ecologists, Virginia and Beth, have to say.
Hi everyone, my name is Gabe DeYoung and I'm an ecologist with the Nature Conservancy in Arkansas, and I'm here today to talk to you about post-burn evaluations.
Hi, I'm Virginia McDaniel, and I'm a forestry technician and ESA certified ecologist with the Southern Research Station of the U.S. Forest Service. And when we were asked to put together this webinar, we thought that maybe instead of just doing a typical PowerPoint talking about post-burn evaluation, that we would get some video footage, some live footage. And we just had a really wonderful fire here on the Washoe National Forest, and so we thought we would use this Red Bank Glade Restoration Project as our demonstration.
Historically, the natural communities on Red Bank Restoration Area would have been a mix of open woodland and glade and savanna, and these would have occurred sort of in a patchwork in the landscape. But all of these communities require frequent fire disturbance to maintain them. And so what we've done to try and restore the glades on this restoration area is to reintroduce fire and also do a lot of mechanical thinning to sort of speed up the process. So here you see a lot of downed cedar and the skeletons after the burn that remain on the ground. These were cut a few years ago, and now this area has been burned twice. And so the fire is both good for keeping encroaching species out and keeping that woody stem density low, but also it will eventually consume all of this down fuel that was left after cutting the cedar. So these glade communities were a natural component, of this landscape, and they're important because they actually contribute significantly to the overall biodiversity of this region. These glades have a lot of unique species in them that are found only in the glades, and many of these species are quite rare and or endemic to this region. So preserving them and restoring them contributes significantly to conserving the biodiversity that is naturally here. Before we jump into actually doing a post-burn evaluation, I just want to talk briefly about how we prepare or plan ahead for doing these sort of rapid assessments. And first, we typically shoot to do a post-burn evaluation from about 2 days after the burn to up to a week from the burn. And this allows for certain things like scorch to show up so that we can more accurately estimate the amount of scorch that will be on trees within the unit. One thing we also, we watch the weather, and if there's going to be a significant rain event coming in, we usually try and get out there before that because it can be sometimes a little more difficult to gauge the burn severity, say in the substrate or maybe charring on trees after a rain event. So keep that in mind. So in our methodology, we walk transects through the unit. These are not permanent transects. What we're trying to do is to really capture the relevant variation within the unit. Are there strong aspects that we want to capture? Are there strong north and south aspects, for example, where we'd expect different fire behavior and effects? We also set these up to capture the dominant plant communities and or fuel models within the unit. But again, these are not permanent. Then what we do is at set distances along these transects, we gather information in plots. And again, these are not permanent plots. And we generally shoot to collect data in at least 20 plots per community or major fuel type. And so the complexity of these post-burn evaluations does depend on, the variation that's present within the unit. So they can be quite simple if it's one community type or fuel model present in the unit to, many different plant communities. Okay, so we're at our first plot, and what we're going to do first is sort of measure out 5 meters from a center point of the plot. And in this 5 meter radius circle, we're going to be looking at burn severity of the substrate layer and of the ground layer vegetation. So Virginia just walked out 5 meters.
Six paces.
6 paces, all right. And in future plots, we won't measure it out. We're just kind of getting sort of eyeballing or getting a good reference for what 5 meter radius is so that we can do this more quickly in our next plots. Alright, so first we're going to take a look at substrate burn severity. So when we're speaking of substrate, we're talking about litter and also duff. And duff is that partially decomposed litter that's still above the soil surface. Litter is all the leaves and thatch, perhaps, twigs that have fallen on the ground and are not yet decomposed. So we're going to assign a substrate burn severity to this, and we have 4 different classes. We have scorched, lightly burned, moderately burned, and heavily burned. So taking a look at this burn substrate here, you can see on the surface there's a lot of charring of the litter, and the litter is at least partially consumed, partially to maybe mostly consumed. On the surface, you're still seeing some leaf structures, but they're not complete. These aren't entire leaves anymore. And the pine needles are heavily charred and partially consumed. And you kind of dig under, and you can see there's still some unburned, a little bit of unburned substrate under this layer of burned leaves. Okay, so that's kind of what we're seeing here. And I think the duff layer is maybe partially consumed, but hasn't been completely consumed, because we're not seeing any mineral soil exposed at the surface. Okay, so there's still some litter and some duff. So based on what we're seeing here, looking at our different descriptions for the burn severities, I'm going to lean towards giving this a 2, which is lightly burned. The litter is charred to partially consumed. The upper duff layer is burned, but wood leaf structures are charred but still recognizable. So you can still see these twigs are burned on the surface, but still pretty recognizable. And again, we're not seeing any exposed soil. One of the things that's helpful when you're doing these post-burn evaluations is to sort of get a reference for what the litter and the ground layer looked like before the burn. And so it's helpful to go to a nearby unburned area and see what was growing and what the litter condition was like before. So that's what we're doing here. And you can see in this unburned area that's the same sort of community and fuel model as our burned area behind us. The litter condition is as follows. We have leaf litter on the surface, some oak leaves and pine litter all intact at the surface. And then if we kind of dig down, you can kind of see the duff layer, so that partially decomposed litter above the soil surface. So this kind of gives you, again, like I said, a reference for sort of determining how much was actually there before and then how much was consumed post-burn. Okay, so here we're going to show you an example of a heavily burned substrate. So there was a downed, dead tree here that was pretty much completely consumed and burned really hot here. And you can see underneath it, there's this white ash sort of on the surface and some discoloration you can see in the soil. And that actually means that the organic content in the soil has been at least partially consumed. And so this substrate has been burned very heavily, and all of the litter and duff has been consumed, and you actually had some soil mineralized underneath it. Okay, next we're going to take a look at the understory burn severity. So we're talking about the grasses and the forbs, and then any woody stems that are under 1 meter tall. So this woody stem here is about waist height, so I'm going to include that also in the understory. And again, we're looking in this 5-meter radius plot and kind of getting an estimate across the entire plot, or a representative burn severity. So taking a look at the consumption of the ground layer vegetation here, you can see that most of the grasses and forbs have been entirely, either entirely or or mostly consumed in this case. You can see the stubs of the grasses, the bases of the grasses that are here, and some are even starting to green up a little bit after the burn. But when you look at some of the smaller twigs and smaller woody stems, you can see they're just maybe lightly charred, but there hasn't been much consumption of that fuel. So this kind of puts us in a situation where, again, the understory foliage has been mostly consumed, but the woody stems have been less affected, certainly have not been consumed. So this puts us kind of somewhere in between a 1 and a 2 for burn severity, and I would probably just assign 2 to this sort of condition, because most of the grasses and forbs have been consumed. But this is sort of a gray area where it's a bit subjective, but you want to try and stay consistent to yourself and consistent when you do these plots within a unit. So here's an example of what I would call moderate burn severity in the understory vegetation layer. So you can see that all of the grasses and forbs have been completely consumed, but also the small twigs and woody plants under 1 meter tall have been consumed. So this would get a 3 for understory burn severity. So one of the things you're going to want to try and do during these post-burn evaluations is capture some of the natural variation that's present within the unit in the plant communities. So here's an example where we walked from a pine oak woodland into more of what's called a glade community, or open savanna. And so you can see that the fuel model has changed here, and that's important. So you want to capture that variation that's within the burn unit. All right, so we're now on this south-facing slope in a pine oak woodland community, and we're going to assess the degree of scorch on the mid-story. So we're defining mid-story as those woody stems that are taller than 1 meter, but under 8 inches diameter at breast height. So sort of your small trees and your shrubs. And we're going to assign a % scorch. So looking at the mid-story in this plot, we have some cedar shrubs that are nearly entirely scorched. So that's, 95% or above scorch levels on that cedar. Then we have some young pine that are growing in the plot as well that are, I would say 75 to 100 on one of them, and then the others maybe 50 to 75. So overall, in the mid-story canopy in this plot, I would probably give it a 50 to 75% scorch.
What about all these hardwoods, Gabe?
Well, these hardwoods currently have no leaves, so we can't give them a scorch %. So, depending on the seasonality of the burn and when you're doing the post-burn evaluation, you might just have to not include hardwoods in your scorch metrics. All right, so now we're going to take a look at burn severity on the overstory, and we're going to look in particular at scorch, and we're going to measure 2 things: both the height of the scorch that we observe on overstory trees, and also the % of scorch in the overstory canopy. So we're looking at trees that have an 8-inch diameter at breast height or above, and we're estimating, how high is the highest scorch on our overstory. And here in this plot, we have several pine trees that are have these brown or yellow needles, so they have scorch, and some of that scorch is reaching over 30 feet high, so 30 to 50 feet I would estimate. So that would be a scorch height category of 3. And for scorch percent, you can see that some of these are almost completely scorched. There's 2 that probably have 75 to 100% scorch. And there's one pine tree here that's almost entirely green. So overall, I'd give this probably an overstory scorch percent of, either on the high end of 50 to 75% or on the low end of 75 to 100%. So it'd get either a 3 or a 4, depending on your what you want to do. So I'd probably give this a 3, 50 to 75%. In each one of our plots, we're also going to be looking at overstory char, and so char is just the burning or the blackening of the bark on the trees within the plot. And we're looking at 2 things, both the degree of char, or how heavily the trees are charred, and assigning a category from light to heavy. And then also looking within the plot at how high the char is up the tree trunks. So we're getting an estimate or sort of an average number for the whole plot for char height, and then also assigning a char degree. Heavy. This example here, you can see the char is continuous on the surface of this tree, but we're not seeing any heavy reductions in bark thickness. Pretty minor, so we can kind of chip away at what's going to fall off. And you can see some of this bark is going to fall off, but we're not seeing any deep pitting or any exposed wood. So it wouldn't get a 3 or heavy char for this tree. Alright, I wanted to quick show you guys an example of heavy charring on trees. So here's an example where the bark has actually been significantly reduced and there's wood exposed below that bark. So this would get a 3 for char degree. So we're at another plot and wanted to show you kind of what we'd consider an unburned plot. So if a 5-meter radius plot is less than 50% burned, then we call it unburned or not burned. And this is important to also record because at the end of this post-burn evaluation, we're going to be estimating the total burn coverage in the unit, and we use the ratio of burned to unburned plots to estimate that number. Here we are still within our burn unit, still doing plots, but we've now entered a completely different plant community and fuel type. And so now we're in a riparian area, which is fuel model 8. And we don't really expect this area to burn that often, and as you can see, it hasn't. But it's still important. It's important to have some of these unburned areas within your burn unit, and it's important to capture this information in your post-burn evaluation. Let's do a plot here. So we'll start with substrate burn severity. Looks like there's a fair amount of litter and dust still present, but the top layer of litter has been consumed, so I'd say it's partially consumed, and that'll get a 2 for substrate. Vegetation in the ground layer also will get a 2. The woody stems haven't been consumed, most of those are still intact, but the grasses and thorns have been consumed. We'll give that a 2 as well. Now let's look at char. Char on our hardwoods is pretty low, actually on our list as well. All so far below 5 feet. So I'm going to give this a 1 for char height. And for char degree, really it's pretty light or non-existent on some. Pretty spotty, even on the pine trees. So this will get a 1 for char degree. Mid-story scorch. We actually have a little bit of hardwood mid-story here, and that's probably 0 to 25% scorch. And what else do we have? Any other young pine? There's some more hardwoods over here. This one's at least 50% scorch. We had some cedar that doesn't look scorched at all. Also part of the mid-story. So overall, in this plot, I'd give it a scorch level of 0 to 25%. So 1 for mid-story scorch. Overstory. So we're going to be just looking at the pine trees here. We do have a little bit of overstory that is starting to leaf out, actually. But I'm not seeing any scorch. So it's going to get a 0 for scorch height and scorch percent. And that's it. After we've gone out and collected our data, how does it get incorporated into a report? Well, it's fairly simple. We basically just calculate averages of the various burn severities. And we do this by the entire unit across all plots and also by communities or fuel types within the unit separately. And so here's a quick example of what that looks like. In this case, there was only one plant community present in the unit, so it's fairly simple and straightforward. It was fuel model 9, maybe with a little bit of fuel model 2 in it. We report the coverage, which was estimated by the ratio of burned to unburned plots. And then you can see the different burn severities and scorch levels, and we give an average for each one across the unit. So that gets reported, and then we also include some discussion of each one of those outcomes. And it's, this is an area where we can expand and give our observations, maybe explain some of the first order fire effects that we're seeing, if we have some insight as to, why we got the results that we did. And then finally, we usually kind of sum it up with a discussion at the end, usually just in a paragraph or two about, whether or not we met our objectives. And if we didn't, explain what those were and perhaps why. And then we also talk about how, the burn ended up contributing to the long-term management goals for that unit, whether it was positive or negative.
Hi everybody, my name is Beth Buchanan. I'm the Regional Fire Ecologist for the U.S. Forest Service in the Southern Region. I want to thank McCree for introducing us to the topic of why we're burning and why we need to connect our data collection with our objectives and to talk about the big picture of everything that we need to think about. I also want to thank Gabe and Virginia for going into the nuts and bolts of the data collection and really doing a good job of explaining what it is we need to collect out there. My topic is other considerations, some other things that you should consider when you start collecting this first order fire effects monitoring data. First of all, go ahead and use existing methods and protocols. There's no need to reinvent the wheel. I work for the Forest Service, as I mentioned, but when we started our fire effects monitoring program, we stole everything that we possibly could from the fire monitoring handbook that was written by the National Park Service. We also relied heavily on measuring and monitoring plant populations, which is a really great book that is actually incredibly readable. It was a really good book. Some of the forests in the southern region use the Composite Burn Index, or CBI, on some of their projects. But I can't tell you how important it is to use existing protocols, because I guarantee that you'll get yourself into trouble if you try to come up with your own methods. In addition, make sure that your data sheets are user-friendly. Again, we stole everything we could from National Park Service, including the data sheets, but they weren't quite exactly always what we wanted in my agency, so we tweaked them. We kept everything that worked for us, and we got rid of anything that we did not need. Does your agency use FEMOs on burns? You know us, we're the federal government and we love acronyms. FEMO stands for Fire Effects Monitor, and the FEMO, if used on a burn, is responsible for keeping track of fire behavior, how people are putting fire on the ground, and what the weather is doing throughout the day. Their sole job is to watch and observe and capture those notes. It's really valuable to have this data along with the data that you collect immediately after the fire, because obviously how you put fire on the ground and what the weather is doing is going to influence your effects. Remember also that photos literally are worth 1,000 words. If you can go out before your burn, immediately after your burn when you're collecting your first order fire effects data, and then subsequently throughout the years and multiple burns as time goes on, that information will be so valuable. I don't know how many times somebody has said, boy, wouldn't it be great if we had pictures of this area 50 years or 100 years ago? Next, be aware that there is absolutely no reason these days to put data sheets in a drawer and leave them there. Software is available so that you can put your data in an electronic file somewhere and then do something with it. Data in a drawer is useful to practically no one. Software that you may have heard of if you're already in the monitoring business is FFI. FFI is free software used by many agencies, maybe even yours, and it's designed for managers. It's designed for those of us that are not statisticians. FFI allows you to store and organize your data without ever physically or electronically cutting and pasting and moving things around like you have to do in Excel. So put your data in, and then you can organize it in any number of ways. And importantly, you can analyze it too. Again, this software was designed for us managers in mind, and so with the click of a couple of buttons, we can run statistical tests and show whether or not we are moving towards meeting our objectives. FFI has the capability of creating simple reports and graphs so that immediately you can look at your results and you can see those changes and see whether or not those changes are the ones that you want. And then, if you want to get fancier, you can export the data into Excel or another program and make them look really beautiful. You want to create these graphs and these reports so that you can inform your burn program. You want to complete the adaptive management cycle. Like McCree said at the very beginning, you want to see whether or not you're meeting your objectives. And if you are, that's great. What are your next steps? And if you're not, then what do you need to do? Do you need to change your objectives? Do you need to change your burning? Do you need to change the type of monitoring that you do? You can put it into a report and you can present it to the powers that be. If your monitoring program is robust enough, you can put it on the internet and share it with the public. I definitely encourage you to share your results with your partners. For example, the Fire Learning Network. You can let them see, you can let all of those other partners see what you've been doing and they can tell you what they've been doing, and you can combine your results even and look at the effects landscape wide. Once you have enough data, you might even be able to inform models. So if you're collecting severity data and you're collecting fuels data, you can use it to tell you what kinds of smoke emissions you're having and maybe even tweak those models. Something that we have been able to do the last couple of years is actually share our data with peers across the country and across the world. Our fire effects monitoring data has been shown at international fire ecology conferences, and we're really proud of that. In my opinion, it's really important to have the firefighters involved with this data collection. It's the firefighters that are putting fire on the ground, deciding how to put fire on the ground, and evaluating when to put fire on the ground. And if those same people can get out in the woods and look at those effects, it's another way to help create the answers that you need in your adaptive management cycle. We're all land stewards. Remember, too, that we are the messengers both to the public and the policymakers, and we're delivering the message that we're doing good for the land. We have the tools and we have the knowledge that we need to make sure that we're telling our story.
Well, wonderful. That was a fantastic video presentation. And I so appreciate being able to see the protocol in the field too. Not something that we would normally get on a Zoom presentation. So thank you to everybody who put that together. So just a reminder, we're going to move into our question and answer period with our panel of experts right now. So please do put any questions you have for folks in the chat and we'll make sure to get those answered. Let's do some quick introductions of our panelists, just so folks know who's on the line with us here today. Gabriel, would you go first?
Hi, everyone. My name's Gabe DeYoung, and I work for the Nature Conservancy in Arkansas, and I'm an ecologist.
McCree?
Hey everyone, I'm McCree Anderson. I'm a fire manager of a fire program here in Arkansas and oversee the Fire Learning Network. I'm here in Arkansas as well and work for the Nature Conservancy. Thank you.
And Beth? Oh, you're on mute, Beth.
Good grief. That's the third time this week I've been on mute. Oh, gosh. I'm Beth Buchanan. I'm the regional fire ecologist with the U.S. Forest Service in the southern region, which spans basically Virginia over to eastern Oklahoma down to Florida. I just want to say thank you, McCree, for putting this together. This is a really great example of what we can do when we work together with partners. So we've got TNC, we've got the National Forest and SRS with Virginia next. Thanks.
And Virginia.
Hi, I'm Virginia McDaniel, and I work for the Southern Research Station of the U.S. Forest Service. I'm a forestry technician and also, an ecologist. I'm kind of combo. So, yes.
Awesome. All right, well, I'd like to welcome other participants to turn on your cameras at this point if you'd like to as well. You can also use the raise your hand feature. You can find that in reactions at the bottom of the Zoom screen. If you'd like to verbally ask a question, raising your hand will let me know you want to talk, and then you can unmute yourself and ask your question. Great, so we've got a question that just came into the chat. What is the role for remote sensing? What aspects of post-fire effects can be effectively evaluated? Who wants to take that one?
Okay, the introvert will answer the question. Remote sensing is becoming more and more valuable. It absolutely is. And if you're looking at a small area on the ground and want specifics, like really precise information, you want to look at plots. If you want to look at species, you want to look at plots. If you want to look at those particular parts of the fuel bed, you definitely want to look at plots. But remote sensing is definitely becoming more accessible to all of us and more valuable to all of us. There's a lot of work, a lot of research that's going on with LiDAR and other tools to look at the big picture. You know, you can't spend your whole career just installing plots. Most of us can't, you know, we're actually out putting fire on the ground and getting ready for fire and planning for fire and putting fires out and all of that stuff. So you've got to think about what your questions are and what your resources are. So if you want to look at landscape scale changes, certainly remote sensing is what you want to look at. You know, you can see big swaths of mortality or, you know, changes in structure, certainly, but sometimes it's hard to see what species were killed. And so then you want to go back to looking on the ground at plots. And I will also say, I think it's incredibly valuable. I said that in the presentation, but I think it's really, really important that the firefighters are out collecting data on the burn units that they that they put fire in, because you know, if we have a disconnect between who's putting fire on the ground and then tracking those changes, it's really hard for the firefighters to know what to adjust in the future. You know, we're out there trying to make changes, and so it's really important to say, oh, okay, I let fire run uphill here and I got the mortality I wanted, or I got too much mortality, or I let it back down here and I didn't kill anything, so I need to adjust how I burned it. Or maybe I got a wind shift here, and so I see that I got different effects here. And so it's really important, I think, that the people that are applying fire are the ones actually out observing the effects as well.
Yeah, that's awesome, Beth. I've had some FEMO trainees work with me over the years, and including some firefighters who saw themselves as firefighters and didn't think they were interested at all in the fire effects, and they ended up just being fascinated by all of that information. So a couple other questions have come in. One from Jason: how do you incorporate post-fire vegetation response? For example, ground flora response is 3 to 5 years post-fire.
I can take that, and that's a very good question. I can speak to sort of what the Nature Conservancy does here in Arkansas and also our partners throughout the state. We do follow up in a lot of cases, in a lot of places where we're actively managing with fire. We do have long-term vegetation monitoring plots as well. So we do measure the second order fire effects. And that's really key. And I think using both these post-burn, immediate post-burn evaluations, first order fire effects monitoring, to also then in tandem work with the second order fire effects monitoring, I think is just really awesome. So seeing the long-term effects through our veg monitoring, we can go back and look at our post-burn evaluations and see how we got there with fire. And so that really kind of helps complete the long-term monitoring and adaptive management cycle.
Yeah, to add to Gabe's comment for Jason is that, you know, what I see is people on the ground that have been there for a few years and did a burn, you know, in a dormant season control burn setting, you know, a cool burn. It looked good for a while. Maybe the first year you could see the effects, and then 3 to 5 years later, you know, you can't see it. And so what that means is that you might need to change up your fire regime, your fire seasonality, or your frequency. And then the other thing is you might take photos as well to help kind of document that journey. Because if you've been there 3 to 5 years ago and you know the process, but if you haven't, then you don't really know what's happening. But this really helps management for sure.
Awesome.
Yeah, I kind of want to second what McCree just said about, you know, taking photo points. I think it's awesome if you have people that know the species and you can go out and do plots. I mean, that is the ideal. That's where we kind of all want to be, but sometimes you don't have enough botanists that are going to be able to identify plants to species. So just getting a photo point, I think Beth mentioned this in her presentation, you know, a photo is worth 1,000 words. If you can just really get that exact photo through the years, I mean, that can, and I think it was Emily that said that you've used that in presentations. I mean, it really, you know, if you're doing your burns right and you're meeting your objectives and you're getting the results you want, it's just incredible to see this.
Yeah, it was a really gratifying moment for me to show a before and after picture and have the whole audience just, oh my gosh. So it's pretty cool. It's a good event. Mary asks, what would be the most efficient tool for monitoring in heavily damaged landscape disturbances such as hurricanes? Transects aren't really the tool for this type of disturbance in nature.
Yeah, you know, you've really got to look at your situation, and Mary, I know we've actually chatted about this. It may even be too dangerous and completely inefficient to get out there and put transects in. So yeah, certainly, you know, using aerial photography. I think that your forest has been flown to capture the widespread damage from hurricanes. You know, you certainly want to utilize those sorts of tools in a situation like that. There is a document, and I don't know the title of it offhand. Here in a minute, I'll try to look it up behind the scenes, but there is a GTR, or General Technical Report, that was put out to look at fuel loading in hurricane damaged areas. And if you have that, you can stick that name in the chat, but I'll try and pull it up here on the internet as well. Yeah, you know, if you're climbing over log after log after log, it's inefficient and dangerous.
Okay. So I'm wondering, what is the time commitment for this kind of monitoring protocol, and how do you find and sustain the staff resources to be able to do this consistently?
I can speak a little bit to that. You know, of course, we try and design these post-burn evaluations to be rapid, but it really depends. The time commitment can be very small. Say if your program doesn't do too many burns throughout the year, you know, then your commitment's fairly small. But if you do a lot of burns, then obviously getting out there and doing these post-burn evaluations can be more of a time demand on your staff. But I think, and then also it also depends on, you know, how large your burn units are as well. That certainly adds more time commitment. But, you know, these evaluations again are really adaptable, and you can sort of stretch out those plots farther, make them farther apart to, you know, move through the landscape more rapidly if you have to. So it really depends. The Nature Conservancy, you know, typically burns for, you know, units between 50 and 200 acres, and those can take, you know, usually about an hour or two to complete on the day of the post-burn evaluation. And then you're talking about a few hours to do the analysis and put the post-burn evaluation together after that.
Yeah, add that in the past, you know, as a fire burn boss, RXP2 burn boss, and a fire manager, we used to not have a Gabe and somebody, and so we were responsible for doing our own. The burn boss was responsible for doing their own post-burn evaluation. You had to go check the unit anyways the next day or the couple of days later. You spend a day and you go walk the site and fill out the data sheet. And then you're responsible for coming back, typing it all up, and owning the burn, owning the effects of your burn. And I felt that for me was really powerful. Over time, you know, we've done bigger projects with the Forest Service and other partners trying to do these types of things on 2,000 to 3,000 acre units. And it's totally doable within a half a day. If you have a vehicle, you have a map, you know your site, you get in your vehicle and you drive to the north facing slope and you do a big loop and swoop across the north facing slope to look at the effects. You get in the car, you go look. So the point is it, no matter the scale of it, I think if you have a vehicle, you can get around these things in a half a day for sure and get your plot data.
Awesome. Well, that leads on to another question really well. Beth, you kind of touched on this, but can all of you talk a little bit about the technology that you're using to facilitate that data collection, both in the field? Gabe, I saw you were using a tablet out there. What are the programs that you're using?
Yeah, it's pretty simple. We have used just paper forms in the past for collecting the data and then entering that when you're back in the office into an Excel spreadsheet or something, and then run your pretty simple analysis the data after that. But more recently, I've been just collecting on a tablet. These are just what we use is just iPads with a spreadsheet software, and we have the template set up, and we can just collect it all on the tablets. So it's pretty simple. Not a lot of technology or tools involved.
And on the other end of the spectrum, folks that have used FFI have said, why can't we put it on a tablet and use it in the field? And that there are so many drop-down boxes and options in that software program that it's been tough to create an easy to use mobile option of that software. It's also a function of funding. The fire monitoring software doesn't get the big dollars that some of the other programs do. But there are attempts in the work to get a mobile version of FFI. So be patient. And if you're interested, I will say that the guru behind FFI does have tough books that he will loan out to people if you want to try putting that information into a program or into a computer directly in the field. So contact me if you are interested in that.
Awesome. All right, well, we're just about out of time, and I want to turn this back over to McCree to close us out. Maybe I could ask all of the panelists to just put your email address in the chat, so if folks have additional questions, they can reach out to you directly. And fantastic, thank you all for answering a bunch of great questions there. And McCree.
Okay, yeah, thanks. Before everybody hangs up, if you have to hang up, please do. But if you can hold on for just a few seconds, Virginia did a really incredible job of creating a long thing on video. So without that, without any more, I'm just going to flip to that. But thanks for everybody for joining. Hit us up if you need me. So thank you.
Post-burn, a rapid fire assessment, cool embers, and a smoking stumble. There is an ordinary fire burning in the woods. Hold tight, wait till the burn is over. Hold tight, we're in for nasty burgers. It's the verity, burning in the woods. Here's your Nomex data sheet, see the substrate at your feet. Is it charred or consumed? Does the veg have leaves attached, or is it burned down to the thatch? Severity 3, jaw height, the blackness on the bark, tree scorch, leaves brown and falling down, 365% burning in the woods. Now it's time to calculate the averages upon the slate. Did you meet your objectives? Did the burn contribute to the long-term management of the land that you set out to do?